Assalamualaikum everyone. So today I'm gonna post my first video on the basics of ECG. As I told you earlier, I'm gonna make the videos in different parts so that it remains really short and it really does not annoy the viewers with the long videos because I know this is kind of boring. So before we get started, few things. If you want to have any suggestions or any comments about the videos, yeah, please do put them down in the comment box. And if you want me to make any videos on new topics or new things that you want to understand with everything, I would definitely do so and consider it. Before we start, a small request, please follow us on Instagram so we can bring you good and great stuff. So before we get started, a lot of things we do about the ECG. First thing up, we know that ECG is the electrocardiogram that shows the electrical conductivity of your heart and heart events that would tell you about how what chamber is working, and any of the abnormality in those electrical events would be presented from normal deviation onto an ECG paper. So what things or what condition could we identify from an ECG? That's a very good thing. And what purpose can we use for? So if we see that, we can use ECG for regular or irregular heart rhythms. We can use ECG to check a person with an angina. We can use ECG to diagnose a person for MI, ischemic heart diseases, even for electrolyte disturbances like hypo and hyperkalemia. QT prolongations that is caused by some drugs toxicity. Of course, yes, I will be discussing all these abnormal ECGs in my later videos and how to interpret them. I would definitely do so. So today I just decided to keep things very basic. So as I told you guys, this is one of the basic stuff and will illustrate on electrical activity and conduction of the impulses in the heart. So we need to have those some conductive systems. So what is that conductive system? You know, we guys have got the SA node that is present in the right atrium. So that SA node would help to generate impulses, and those impulses will travel throughout the heart. So you know guys that this SA node is actually the main pacemaker of the heart. But what if this pacemaker got malfunctioned? So who is gonna take over to those function or those responsibilities? Yes, I will tell you. So this SA node will generate some impulses, and these impulses will travel to the AV node. But first thing up, this SA node will also send some impulses to his neighbor, and that neighbor is the left atrium. Yes. So the SA node will send some impulses to the left atrium to the AV node. AV node will transmit those impulses to the bundle of His, and bundle of His will generate and will send these impulses to left and right bundle branches and then to Purkinje fibers. I have written them in an order of sequence how the impulses would travel and how will it go. So in the next diagram I will show you. So the thing up, if an SA node is not functioning, is not going for his responsibility, so who's gonna take the responsibility is the AV node. So if you see in this SA node, we see three fibers coming from the SA node that goes and innervate into the AV node. What are these three fibers? One, two, three? No. There is one fiber that is missing, so I will find a good picture for it and I'll definitely post in the group. And that one fiber is the Bachmann's bundle. Those Bachmann bundles will travel from the SA node right atrium to the left atrium to transmit the impulse. I think I'm very wrong using the term transmit the impulse is action potential. No, I should be using the wave of depolarization. Yes, because when you talk about the conductive system of the heart, you have to talk about terms of depolarization, repolarization. So you see these internodal pathways. These internodal pathways are of three types. You have a posterior, that is Thorill's internodal pathway, middle, that's called Wenckebach, and anterior, which is called anterior, of course. So these pathways will innervate into AV node. AV node, as you see, goes into the bundle of His. And as you see, the bundle of His would be present in the interventricular septum of the heart. I'll show you in the next picture. And these interventricular septum of the heart will give a rise to the left and right chambers of the heart, and those bundle of its fibers who will bifurcate into right and left bundle branches, and that will supply to each and specific chambers of the heart. And these right and left bundle branches fiber will definitely innervate themselves in terms of Purkinje fiber into the lower myocardium. So as you see in this picture, it shows about all the electrical activity and conduction of the heart. How does it go? How does the action potential fire? Yeah, it's too basic for you guys, I know, but just to keep a small introduction and then to move up onto the big stuff would be easier if you have some little basic knowledge. That's what I believe. So, as you guys all know, on ECG, we usually have some waves going up and down with different amplitude. Those are very special waves, in fact. So, as you see in this waveform of ECG, we have got a P wave. That's a Q wave, R, S, T, and U. That's so simple. Not that much actually. Yes. So if we see this P wave, it shows something. I use the word depolarization. Yes, it changes the action potential in the upper chambers of the heart. It's actually a wave of depolarization. It depolarizes the atria. It depolarizes the atria to make them contract. Then you have got the Q wave. The Q wave activates the anterior septal region of the ventricular myocardium. And if you see, we consider this QRS as a whole complex in it, and that's called a ventricular depolarization. But I have made small notes on this R waves, Q waves, and S waves separately so that it gives you a good idea. So R wave will depolarize the ventricular myocardium, whereas the S wave will activate the posterior basal portion of the ventricles. Okay, so as you remember the action potential of the cardiac muscles from cardiac physiology, yes, in that action potential you see it starts with a wave of initial depolarization, then it goes to repolarization, and you have plateau phase, then you have final repolarization. Yes, so if you illustrate this diagram of ECG with that action potential, you will understand with PQRS complex you have depolarization. But as soon as there is a T wave on ECG, this T wave will definitely illustrate you the repolarization. But you will see very rarely some U waves, and U waves are thought to be present in response to repolarization of the Purkinje fibers. But very rarely you guys would see to this U waves. So that's the very basic things. Next, we move on upon the grid of ECG. What are the ECG grid parameters? What are the ECG grid elements that would help you to understand the duration of each waveform, the time, the amplitude? So if you remember on a graphical presentation, you have an X or Y axis. That's correct. So what is the most important thing you need to understand while interpreting an ECG? And that is the speed of the paper. The speed of the paper of ECG is usually 25 mm per second. So you see on the graph paper of an ECG or electrocardiograph, to be very specific, yes, it consists of larger boxes and it consists of very small boxes. So I'll show you a picture of one of these graphs. So if you see here in the picture, we have got this big boxes that is outlined by a dark black. I'm not being racist, but yeah, it's a dark lines of boxes. Okay, so if you see horizontally on the horizontal axis, each big box, each big box will illustrate a duration of 0.20 seconds at a typical paper, which I will tell you again is working at a speed of 25 mm per second. And these big boxes are divided into smaller 5 boxes. 1, 2, 3, 4, 5. That's great. Okay, so they are divided into 5 boxes smaller. Okay. And each of these smaller boxes will represent 0.04 seconds. So on the vertical axis, you have got the same scenario, but on the vertical axis, you have the large boxes that also have 5 subdivisions, okay? And these 5 subdivisions, one of each will represent 1 mm. And definitely yes, if the paper speed is 25 mm per second. Okay, so this 1 mm represents the height of each box. So if you have a standard calibration like this, as I have shown in this diagram, like 10 mm will represent 1 millivolt of voltage produced. Okay, so that's the basic things. I hope you get it and very easily. So what do you know about the ECG representation on the graph? Will the waves remain the same with the amplitude, with the duration? No, it changes. It's a very basic things. You see in the beginning I said SA node is the pacemaker of the heart. The impulse that it produces like 60 to 100. For example, SA node it produces the impulse and the waveform is shown is like a P wave. That's atrial depolarization. Now you know the P wave is too small to be seen because the impulse is too small to be generated. That's why it is shown like this. But what if the impulse is very high, the amplitude is high, so the impulse will correspond to a bigger waveform. So to be very honest, small voltage will produce small depolarization, whereas the larger voltage will produce larger depolarization. But it also depends on the size of the chamber. So this means if a person has hypertrophic chambers, so the voltage of the depolarization would be definitely increased, will be enhanced in terms of time duration and in terms of amplitude. So this is up for the basics of ECG today. Yes, I'm gonna post a next video on another basics, that is how to use the leads, how to apply them on the body, what types are there, and why do we have 12 leads. Yes, and also I will have some touch on the basic coronary supply of the blood so that you can know which part of the chamber if it's infarcted. So how will it be represented on the ECG waveform.